All right, here we go with lesson 12 on sequences again. Okay, remember from last time a sequence is just a function. They are often represented by an ordered list of numbers like 1, 2, 3, 4, so on and so forth, where each number in the sequence is called a term. We often are going to represent a sequence using the letter A, and every term in the sequence can be written in terms of A. Remember, so when we look at the first term of a sequence, we would call that term A sub 1. Remember, we wrote it like this, A with a little 1. The next term would be A sub 2. And it just meant the spot in the sequence that the term was in. All right, so let's look at the bottom. We have this other notation too. It says consider the following sequence 3, 6, 12, 24, 48, 96. And it stops. Okay, notice it doesn't keep going. So we have what looks like 6 terms in this sequence. We have this new notation. We're going to start using function notation also to represent the terms in a sequence. It means the same thing. In other words, A of 3, like that, is the same thing as A sub 3. They're the same thing, just two different notations. We do want to be familiar with both of them. So this says find A sub 3. Well, that's 1, 2, the third term, and that's 12. A sub 3 is 12. Find A sub 1 plus A sub 4. Well, A sub 1 is 3, and A sub 4 is 24. So let's just plug those in. A sub 1 is 3, A sub 4 is 24. Again, it's the term in the first position and the term in the fourth position. And 3 plus 24 is 27. Okay, so again, A sub 2 here, that's the same thing as writing it in function notation like this. Okay, and it just means the second term, which is 6. Over here, now let's find A sub 2 and square it. So A sub 2, again, was 6. So we have 6 and square that. So that is 6 squared, which is 36. The next one, A sub 5 minus A sub 3. So A sub 5 is here, the fifth term, and A sub 3 is here, the third term. So that looks like 48 minus 12, and that equals 36. And finally, solve for n. A sub n equals 96. Well, again, remember this n is just simply the term number that we're looking at. And so I look up here, I see 96 is here. So let me count. 1, 2, 3, 4, 5, 6. So A sub n equals 96. N must be 6. It just means the sixth term is 96. A little kind of cheat, a little pointer thing here is the input is always the numbers placed in line. So you can always count like I just did to find 96. 1, 2, 3, 4, 5, 6. It's the input, the x value, the piece going into the function is always just the numbers placed in line. So the terms spot in what position it's in. All right, so what about graphing a sequence? Let's consider the sequence defined by A sub n equals 2n minus 1, or A of n equals 2n minus 1. If we want to write the first 5 terms of this sequence, well, we would simply we'd look for A of 1, A of 2, A of 3, A of 4, and A of 5. And A of 1 would be, I remember, with a function, I just stick this in for n, right? N became 1, so now I'm looking for 2 times 1 minus 1. 2 times 1 is 2, minus 1 is 1. That's not too bad. Well, let's try that again. So in this case, n is now 2. So 2 times 2 minus 1. 2 times 2 is 4. 4 minus 1 is 3. Let's plug in 3. 2 times 3 minus 1. Well, 2 times 3 is 6. Minus 1 is 5. A of 4, I have 2 times 4. Minus 1. 2 times 4 is 8. Minus the 1 equals 7. And finally, 2 times 5 minus 1. 2 times 5 is 10, minus 1 is 9. So the first 5 terms of the sequence would look like this. I would have my curly bracket, and I would go 1, 3, 5, 7, 9. Those are the first 5 terms of the sequence. Now if I want to graph this sequence on the interval where n is between 1 and 5. Remember, n is just going to be what position we are in. Okay, these are like your x values. It's your domain. Okay, so if I want to graph this sequence on the interval 1 through 5, I'm looking down here. 1, 2, 3, 4, 5. And when n is 1, what is my function? So this is a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. Or you could write it again like a of 1, a of 2, and so on and so forth. So when I put in 1, what did I get? I put in a 1, I got a 1. So I go over 1 and up 1. Let's do it with 2. When I put in a 2, I got a 3. In other words, the second term is 3. So go over 2, up 1, 2, 3. And then I go, let's see, for a sub 3, the third term is 5. So go over 3, up 1, 2, 3, 4, 5. The fourth term is 7. So over 4, up 1, 2, 3, 4, 5, 6, 7. The fifth term is 9, so 1, 2, 3, 4, 5, 6, 7, 8, and 9. Alright, so here is my graph. I can take and put a line through this. It would look like this. And right, I could put a little arrow on the end if I wanted. Okay. So now the next question is, should this be continuous or discrete? Well, yeah, I mean, I just graphed a bunch of points and they're all in a line, right? So I just have to draw the line. Well, is that true? Let's see. So the first position was 1. The second position was 3. Do I have a position between 1 and 2? In other words, do I have a position that's at 1.5? Should I put 1.5 in there? Would that make any sense? Not really, okay? Putting in 1.5 here doesn't make sense. I'm looking at actual spots in line. Okay, if you had a whole bunch of people in line, you would count off by integer numbers, by the natural numbers, 1, 2, 3, 4. Someone wouldn't be the 5.5 person in line. Therefore, that makes this not continuous, but it would make it discrete. Remember, discrete graph is one where you're simply putting in the points. So let me put this in and delete it. Well, I can just move it out. Whoops. Okay, so I don't want this to be all connected. Okay, so I have to make sure what I'm doing is making sense with the function here, or the sequence in this case. Looks like I moved this a little bit off. There we go. Okay, so this is discrete. Remember, the discrete graph is only dots along the way. We don't connect the dots. And again, how do you know you're not connecting the dots? Because it doesn't make sense to have a position in between the first and the second position. Okay, now could I in turn find the 21st term of the sequence? I mean, I just stopped at 5 because I just only wanted to do the first 5. That's all I was asked for. But could I find the 21st term? I think I could. All I would need to do was just type in or plug in 21, right? So I would say a sub 21 equals 2 times 21 minus 1. And 2 times 21 is 42, and 42 minus 1 is 41. So the 21st term is 41. And if I wanted to write that as a coordinate, I would have 21 comma 41. Right? And I could easily graph that point. So as you see, graphing a sequence, it could be just a series of dots depending on the type of sequence. In this case, they do seem to make they have a linear relationship, but the graph should stay discrete. They should just stay as points, and we should not be connecting them. Okay, well that's all. It was just a quick recap of sequences. This is something that should kind of be ringing a bell from earlier this year. The next video we will be talking about this special kind of sequences called arithmetic, which again we've already seen once. So these kind of next two, this lesson and the next one are both somewhat review. I guess just bring your notes next class and we will be working on it. See you then.